Light. It affects our mood, the environment around us, and how calm we are. Feeling that the light in my room could be improved, I set out to build a clean and convenient lighting system. Because I also wanted precise control over the brightness, I knew that a light switch wasn't the answer, and I went to build a new way of controlling my room's light. I found that a rotary encoder would be perfect for this project. Using its rotating mechanism, it should be very simple to adjust the brightness of the lights. Its integrate button can also be used to toggle the lights. I paired it with the easy-to-use Wemos D1 Mini to create my transmitter. With the design of the dial figured out, I 3D modeled everything inside of Fusion 360. I wanted the dial to look minimal and polished since it would be on my desk and always in view. The bottom and top parts of the enclosure will be printed in matte black PLA. I decided to have the middle piece be CNC'd out of brushed aluminum to give it a more premium look and an accent color. Making the LED controller was slightly more complicated, and I chose to design a PCB to keep it clean. Here's a schematic for the LED controller, which, like the dial, also uses a Wemos D1 Mini. Since the lights are powered through 12 volts, the LM7805 voltage regulator steps down the voltage to 5 volts so that I can safely power the microcontroller. When I finished the design, I sent the files off to PCBWay, who is also this video's sponsor. PCBWay is an easy-to-use, trusted, and affordable PCB manufacturer. Using their online tool, you can quickly upload your Gerber files and choose from a variety of materials and finishes for your PCB. Alongside PCB manufacturing, they also offer PCB assembly, CNC machining services, and 3D printing, which you can use to easily build this project. PCBWay will also be hosting a winter sale this month, so be sure to check them out in the link below to learn more. When all of the parts arrived, it was time to start soldering the boards. The PCB for the LED controller came out very well, and it looked very sleek. The quality was also great like usual. I first started by soldering the barrel jack for the 12 volts power input, and then the voltage regulator. I chose to make the Wemos D1 Mini detachable with the help of some pin headers on the PCB. This will make things much easier for when I need to upload the code and take out the microcontroller. When I tested the circuit, the voltage regulator exploded. The issue was that I messed up the polarity for the DC barrel jack in the schematic, which sent 12 volts to the output of the regulator instead of the input. This was a good reminder on how important it is to wear safety glasses when working with electronics. Because I didn't want to wait for a new PCB to arrive, I instead used some wires and swapped the positive and negative points on the circuit. The updated and fixed PCB can be found in the description below. After I was finished with the PCB, I soldered the rotary encoder to the D1 Mini. Here's how both of the boards turned out. I then 3D printed the parts for housing the electronics. I decided to not use any screws for the LED controller since it already fit pretty well, and adding heatset inserts would mean increasing the size of the case. The barrel jack simply slid into the cutout without needing any extra glue. To assemble the LED dial, I used some heatset inserts for the bolts to thread into. I glued the electronics into place and screwed in the middle plate that was made by PCBWay through their CNC machining services. I was very impressed with how the aluminum middle plate came out and with how the brush finish looked. The middle plate's dimensions were accurate and everything fit into place like planned. I used the included nut that came with the rotary encoder to secure it to the plate. Lastly, I finished everything up by sliding the knob onto the rotary encoder. With the hardware finished, I had to start making the code that would control the lights. I decided to use ESP-Now as the method of communication between the dial and LED controller because of its low latency. This is important since having laggy lights sounds like a pretty annoying experience. Setting up the code was simple, since ESP-Now comes built in on all ESP8266 boards and doesn't require any extra hardware. With the code uploaded, I soldered some wires to the end of the controller and slid the Wemos D1 Mini back in place. I then started on the lighting portion of the build, which uses a 3-pin RGB LED strip as the light source. The light strip that I'm using came with a different controller, which I desoldered. To make the LED strip look cleaner, I 3D printed some channels to hold it in place. Because I was limited by the size of my 3D printer, I split the channels into segments which I attached together with the help of some nuts and bolts. The channels were just wide enough to fit the LED strip. I also 3D printed some light diffusers in white PLA that easily slid into the channels. It took a couple of times to get the thickness right, and while they don't perfectly diffuse, they're good enough for something that won't be in a very visible location. I then soldered the wires to the LED strip and controller. On my first try, the lights didn't turn on when I tested them. It's important that the wires are at the beginning of the LED strip where the text goes from left to right, otherwise they will not work. I chose to attach the lights to the back of my desk. Since they were fairly lightweight, some hot glue was enough to keep them in place. The 3D printed channels helped a lot when it came to making sure that the lights weren't crooked. Since I was also reusing an old LED strip with almost no adhesive left, the channels provide an even surface to attach to the desk. The last thing to do was to plug in the controller and dial. Overall, I'm pretty happy with how the design turned out. The dial is sleek, minimalistic, and perfectly fits in with my setup. The lights are bright and the LED controller is small and easy to hide. The latency between the lights is also extremely low, and changing the brightness is both very satisfying and extremely convenient since I don't have to mess around with an app or laggy remote. This design is also modular, and because ESP-Now supports multiple receivers, you can make even more LED controllers and have them easily sync to a single dial to create a full room lighting setup. This build was a great addition to my desk setup and room, and if you enjoyed this video, make sure to subscribe and I'll see you in the next one.